Hey everyone, I'm Mike. I'm here today to talk about ServiceLab. It's our pre-production performance testing platform at Meta, and it enables us to help developers find tiny performance regressions before they go out to production. So at Meta, we operate a hyperscale intranet service. What this means is we have tens of thousands of software services running on millions of machines. And so what I'm showing you here is a simplified graph of a set of services that we have and how they operate together to operate our product for our users. And so we have a diverse set of services. They serve a whole set of different functions. So they range from ranking services to data aggregation, key value stores, cache, databases. And to illustrate the problem of performance testing, I'm going to talk about one of these, front FAS. This is our front-end web service. It's a serverless function as a service platform. It runs on over 500,000 machines, and we have thousands of developers making thousands of changes to the service a day. And you also note that it also depends on many of these other services here that I'm showing here. And so these characteristics of the service has led to several challenges with building a generic performance testing platform. The first is that given the number of changes and given the large footprint of the service, we need to catch tiny regressions. These tiny regressions can accumulate to a large effect if we don't catch them. So what I'm showing you here is a CDF of all of the found regressions that we've found in ServiceLab over the 5 years we've been operating this, or front FAS. And I'll point out that the median found regression size is 0.14%, so relatively small. And if we sum up all of the regressions that were smaller than 1%, this would sum up to over 545% over 5 years. Or in other words, this costs over 2.5 million machines if these were left undetected and not fixed. The second challenge is that in order to do this amount of testing, we need on the order of thousands of machines a day to test all of the changes in front FAS. And to do these performance tests, we don't have a sufficient number of identical machines. Even though we have like millions of machines, the heterogeneity of these machines means that it's hard to find identical machines to do this exact performance test. So like in our fleet, we may have hundreds of different types of CPU models, RAM, disk, NIC models. And so if you consider all these together, the number of identical machines of each type is not very large. The third challenge is that we want to build a generic platform that covers these diverse sets of services. And so the challenge here is that we need to be able to derive a representative workload for all of these services. And additionally, due to these frequent code changes, these representative workloads may also change over time, which means that we have to adapt our performance workload to these changes. Additionally, these target services may also depend on downstream other services. So how do we set up a test environment to fully test our services? And there's also a long tail of considerations for all different kinds of services here. And so we need to be able to cover these for performance tests. And so our goal in building ServiceLab is to enable automated performance testing for developers to help them catch tiny regressions early. In building this, we've come up with these three design choices to solve these problems. So since we have insufficient identical machines for hyperscale testing, we use heterogeneous machines, and we pick ones that are nearly identical. Additionally, to detect tiny regressions using non-identical machines, we've come up and applied some new statistical tests to be able to catch small regressions across a diverse set of services. And additionally, to cover a very diverse set of services, we've leveraged a record and replay of RPC traffic to generate testing workloads. And we allow our test environments to call into their dependent production services. And also, we've had to develop other techniques to support sort of the long tail of these diverse set of services. So today, I'll talk about ServiceLab. It's our pre-production performance testing platform. We do A/B performance testing on heterogeneous cloud machines. It covers over 50% of our code changes at Meta and detects regressions as small as 0.01%. We've been operating this platform for over 7 years in production, and it's helped us prevent regressions totaling over 12,000% of our capacity. And so for the rest of this talk, I'll first walk you through what a performance experiment looks like and how we use the experiment design to support a diverse set of services. Then I'll talk about the key factors we use to allocate nearly identical machines. And then I'll talk about some of the methods that we use for detecting tiny regressions. And then I'll come back to some of our production experience on front FAS. So let's imagine you're a developer at Meta and you're putting out a feature. And so you may have your commit graph may look like this, and you're trying to understand the performance change of the performance of your change. First, you'll create a ServiceLab experiment where we set up an A/B performance test to test the change, and here we create the experiment environment. Next, we allocate nearly identical machines to do this performance test. And then we clone the production configuration of the production service and apply this to the test environment. And so what this means is we build the service binaries that are being tested and deploy them to these machines that we just allocated. But once we have this deployment, we need to come up with a performance benchmark to understand the change in performance that this commit will have. And we want to be able to do this in a generic way, and a way that's also representative of production. And so what we do is we take production RPC traffic, and we sample that and store it to a data store. And when we want to run our performance experiment, we simply replay that RPC from storage. And this allows us to have a more maintainable benchmark versus something like a handcrafted synthetic benchmark, because our services here are fast changing, and we want our benchmarks to be able to adapt to changes in either the code or the traffic. And so by continuously recording RPC traffic, we have a continually updated performance benchmark. So even though we're replaying these RPCs, we still need to be able to execute any dependencies coming from downstream services. And given the complex nature of some of our services, they may have many dependencies. So one thing we could do is simply just clone the production environment fully and create a fully test environment and have our services call this test environment. However, given the nature and the large nature of our services here at Meta, this is practically infeasible at Meta, just being able to fully clone the production environment. And so instead, what we do is we allow our test environment to call into certain production services, but we don't allow any write calls for safety. And if the developer chooses to test write performance, they may be able to override the test data stores or provide mocks instead. And so after the experiment is run, we analyze the results and run a statistical test and report back to the user whether or not their change has regressed performance and by how much. Okay. So now I'll talk about some of the key factors that we use to allocate nearly identical machines. So every machine at Meta has more than 20 documented hardware factors. There are many factors that go into defining a machine. And they may run also as well many different software versions. So we run many different kernel versions as well. And there's also many undocumented hardware factors that go into these machines. And so our challenge here in running performance tests is being able to identify what subset of factors are important for us to reduce the performance variance when doing these performance tests, and also have a high chance of finding these set of machines with these same factors to run our tests on. And so to identify these factors, we analyzed a large set of performance benchmarks. We looked at over 21 million hardware benchmarks and included some real-world performance tests from ServiceLab to understand which factors are important in picking our nearly identical machines. We performed an ANOVA analysis and identified these 5 key factors. The first 4 here, server type, which is similar to instance type in the public cloud, CPU architecture, kernel version, and whether or not CPU turbo are enabled. These are more hardware factors, and there's kind of this obvious implication of why they may be important for performance measurement. But the last factor here, data center region, is due to our choice of making direct calls to these production services. And since these dependent production services may have either capacity or configuration in these different regions, the performance testing becomes sensitive to picking which data center region we do our tests in. And so these key factors account for 87% of our variance, and it allows us to choose machines with a high success rate of these matching factors when we need to select these machines for tests. Next, I'll talk about some methods that we use to detect tiny regressions. So to get more confidence in our measurements, one technique is just get more data points. And so we introduced this idea of trials, which are just multiple replicas of an experiment setup, and that allows us to get more data points in parallel as we run these experiments. And so what I'm showing you here is just a graph of the number of trials and how we can reduce the confidence interval of our measurement as we add more trials. Next, we also observe that different services and metrics may have different probability distributions. And so we came up with different statistical tests to apply to different services and metrics. What I'm showing you here is just a list of the ones that we've used. I won't have time to go into detail of what these are exactly, but I just want to show how we've had to use a different set of tests to be able to detect tiny regressions, and not one test kind of stands out and dominates the rest. Additionally, since again we're in kind of a fast-changing environment where the code of the services may change and the behavior of these services may change, we've had to apply an adapted method to continually pick which statistical method works best over these metrics. And so what we do is we look over a historical period and pick the best statistical test for a service or metric. And to give you a sense on how often that changes, over a 90-day period, more than half of these metrics require changing which model we use. And more than 10% of these metrics, we've had to change the model at least 4 times. And so now I'll talk about some of our production experience. We're finding tiny performance regressions in ServiceLab. So recall I talked about front FAS. In our paper, we talk about our experience with working with some of these other services here, so I'll encourage you to check that out. One of the challenges with front FAS is just the sheer number of changes that go into it each day. And so we can't actually run a performance test for every single one of these changes. And so what we do is we use static analysis and code profiling to select the subset of these changes that we view as most likely to cause a performance regression. And of that, we end up selecting 23% of these changes. Of these changes, only 0.3% of these changes ServiceLab signals for performance regressions. And when that happens, we give a report to developers, and they're able to give us feedback as to whether or not these are true or false positives. Of those, 57% of those developers reported as true positives, 15% of those reported as false positives, and 28% of those, they just kind of ignored us. And so assuming that these unknowns have the same false positive rate, we have an overall false positive rate of 21% of these 0.3% of changes that ServiceLab signaled. And so today I talked about ServiceLab and our experience with using this with one of our key services at Meta. I want to point out that detecting tiny performance regressions is really important for us. We want to be able to empower our developers to find these performance regressions early and fix them. Equally important in operating this performance testing platform is maintainability. We leverage on-demand heterogeneous cloud machines to be able to do our testing. And we also use record and replay to make a more maintainable performance testing workload. And we allow our test environments to talk to production so that we don't have to maintain a separate test cloud environment. Yeah, thanks for listening to the talk. I will take any questions now.